Welcome to EyeOpener, powered by Siemens. And now, your host, Gugan Sanger.
Hello, and welcome to EyeOpener, powered by Siemens. On today's episode, I'm delighted to be joined by James Loach, Head of Research at Siemens, where we are going to be discussing the topic around how to scale predictive maintenance. So, big welcome to James. If you could start off by introducing yourself, that would be great.
Yeah, hi. Yeah, so very happy to be here. By way of introduction, so my background is in experimental particle physics. Okay, so I did a PhD searching for solar neutrinos down a mine in northern Canada. Okay, that was mainly doing sort of analytical work, simulations and so forth. After this, I moved to the US to work on dark matter experiments and switched to hardware, so building like high precision radiation detectors and the electronics that went with that. That experiment was down another mine in the Dakotas, right? After that, I moved to Shanghai, where I became a physics professor, and again, normally sort of working on dark matter experiments. After I left that, stayed in Shanghai, tried to create a little startup. After a year or so of that, I ended up returning to the UK, switching to machine learning and artificial intelligence, the things I do now. Came across Sensei, okay, and so I've been at Sensei for 6 years. And responsible for developing the algorithms and part of the product development, this kind of thing. Okay, so that's potted history. Yeah.
Perfect. Well, thank you so much for joining me on today's episode. And I guess, let's just get started into this topic of how to scale predictive maintenance. So I know you touched on some of your background, James. It would be good to understand why you decided to join Sensei Predictive Maintenance and maybe getting a bit more information about that. Just touching on this whole topic of predictive maintenance.
Yeah, it's something that happens to a lot of people in academia. There's quite often a period comes where you're switching from academia to industry. For physicists, it's very natural to go into what I do now, machine learning and AI. Okay, and the little startup that I had in China was actually using machine learning, trying to build tools for helping people learn Chinese and things like this. Okay, but I was sort of basically in this kind of area, this kind of technology, and coming back to the UK, I just found Sensei just seemed like a nice opportunity. It's sort of early on in the story of the company. Okay, so 6 years ago now, and just lots of opportunity at the time to learn, right? And then also, to help build and shape the product, all of this kind of thing. Maintenance itself has never been particularly a big thing, right? In career before, but I think just in terms of like an area to, deploy my skills and learn, right? It was very nice, and it sort of turned out very well, right?
Perfect.
Nice opportunity.
Yeah, really good. So, James, that takes me to the next question around what is the fundamental problem to solve when it comes to predictive maintenance?
Okay. So the fundamental problem that Sensei is trying to solve, and that I've been a small part of, is getting predictive maintenance to scale. Okay. So, there is a very rich history of people trying to solve this problem in particular industries or with particular machines, doing, particular kinds of like complex specific models and what have you, right? But what Sensei is all about is trying to solve this problem, basically, predicting when machines are going to fail, but do it, in a scalable way so that you have the same sort of core technology application product that you can apply to all different kinds of machines, right?
Okay.
And if you want to scale, this is what you have to do, right? It has to be compatible with the machines that the users are bringing to you, okay? It has to be easy for them to set up and get going, right? Okay. But I think from an analytics perspective, the key thing is making it compatible and useful with all kinds of machines producing all kinds of data. Yeah.
Okay. And how do you... what's some examples of how to scale predictive maintenance? What does that look like?
Yeah, I mean, there's lots of aspects that that we can discuss. But I mean, what it looks like, is that people have got, a bunch of conveyors or robots or fans and things like this, and they want to be able to monitor it in a database way, predict whether things will fail, etc. And they're able to do that without having to climb over some huge barrier, right? So they don't have to bring expensive experts in, build custom models, build custom solutions, right? So it's like the increment of expansion, from zero up to whatever is sort of straightforward and can be handled by people who are close to the machines, basically, right? Yeah.
So it's very much of a transition, isn't it? It's like a phase. You have to, I guess, essentially when it comes to scaling, it's always a phase that you have to go through to get to where you're looking to achieve the end goal.
Yeah, it's like a super important part of things, right? And it's just this increment, right? The increment has got to be relatively cheap and straightforward. Otherwise, you just don't do it, right?
Yeah.
Like traditional approaches, the non-scaling just means it's just very expensive to add each new type of machine and slow and da-da-da. Yeah.
So, James, from your perspective, perhaps you can pick out some key insights that we could look to discuss in a bit more detail.
Yeah. Okay, so I can do that. But I just say one more thing on the big picture, which I think is important at Senseye, is, that this problem of scaling predictive maintenance is something everybody would like to solve. And, I pick out some things we can talk about our specific solution. But I think one thing that's important with Senseye is just the general attitude of the company to solving this, And I think important in that is that, as well as a wish to solve it, there's been a sort of genuine belief that we could do, right? And that we're looking around trying to find a solution that's somehow out there, but at the same time being extremely flexible about how we actually approach that, And Senseye's always evolved with the market, obviously from the very beginning as a startup, right? And, the discipline of the customer through all of that process in sort of, guiding us towards, that end point, right, has been extremely important, so we've not approached it with like some academic view of how it should be done or some papers in hand or algorithms or things like that, right? So I think that's a very, very important thing at Senseye, right? I mean, in terms of specific things that we could discuss as part of our solution, right? So one of them is the idea of decision support. So to me, a scalable system has to be a decision support system, and we can talk a little bit about what that means. The second thing, I guess, is you can never get rid of all the complexity in a system like this, There has to be some somewhere, but you have to locate it in the right place, as well as minimize it, but locate it in the right place so that it's not demanding too much of users, and it helps to support a trustable, understandable system. And then the third thing is, looking at predictive maintenance more broadly than an app or algorithms as like a way of doing things, a way of seeing things, right?
Okay, no, that makes sense. So it would be good to understand what you mean by decision support and why it is so important. Okay.
So the thing with this, right, is so, we're monitoring data from machines and looking for potential problems, The data on its own means absolutely nothing, literally nothing, just ones and zeros from sensors, right? And if you're going to use that to help you in your maintenance strategy, you have to know what this data actually means, And so the meaning of the data and what matters about it, like we can call context, and you have to have some kind of context. And like in traditional systems, that context has been built in to specific solutions by experts. Like it's a algorithm for monitoring such and such robot doing such and such task. So deciding what algorithms to use, how to parameterize them, how to visualize the data, all of those decisions are a way of putting information in the system about what matters. And then the user of such a system, gets their instructions out of it, right? But with a scalable system, you can't do that. That's the unscalable thing, right? Is having the expert there all the time. But yet you still need context, right? And so this is where decision support comes in, right? Like we decide to use the user as the source of this information, They may not be quite as knowledgeable as the expert, right? But they have two very nice features. One is that they are there using the app, you have access to them, right? And you always have a user, right?
Okay.
And they usually have some sense of what matters and what's going on, right? They have hands-on experience and know what they care about and what they don't care, what they don't, right? Okay, so we imagine the app as an AI agent, okay, that the user works with, okay, to help make better decisions and focus their attention where it's needed, right? And the goal of the system all the time is to try and extract as much knowledge from the user as possible, right? The context about what's important and what matters, right? Okay, and I can carry on saying a little bit more about this, how we actually show this in the app.
Yeah, okay, that would be really useful to go into that.
Okay, so the way we do this in concrete terms is that we form the system as a recommendation engine or a recommender system. Okay, so how to say, right? Like analogy or standard analogy for such a system would be something like Netflix, like recommending TV shows to you or movies, okay? And the algorithm that's doing that is not, it's not interested in understanding how movies work. It doesn't have access to the detailed dialogue or whatever, right? What it's just trying to do is to give you suggestions that you will watch and make you happy and try to maximize basically the feedback it gets, either from you having watched it or from giving it a high score or something like that, okay? And the Sensei app is doing something similar. What it's doing is it's looking at machine behavior, all different kinds of behavior going on different sensors on different machines, and trying to estimate how interesting that behavior is likely to be to the user based on what the user has told us in the past, and based on some basic sensible defaults that we build into the system. Okay, so the idea is when you turn on the system, you get some sensible, out of the box behavior. The system then tries to learn from the user which of the alerts that they got were things that they liked. What was it about them that they liked? What are they interested in? And really just works to try and maximize the quality of the feedback that the user gives. Okay. Which is a weird way of looking at things in a certain sense, and I think is totally unique to Sensei, right? The goal is not specifically at the heart to predict when machines will fail or predict this or predict that. It's just to make the user happy, right? Okay. On the assumption that the maintenance engineers will be happy when their attention is well directed and their time well spent. Okay. And this relates to the context thing. We don't have access to physics and engineering or all these details of the machines. Okay, and so in the app, this is expressed in terms of the attention index. Okay. So for every machine at every point in time, we calculate this number between 0 and 1, and that's our estimate for how interested the user is likely to be in it. Yeah, and we direct the attention of the user to the higher ones. Okay, and learn over time to try and refine that ordering. Right. Okay, sorry, I spoke a lot, right? But it's,
No, that's fine.
That explains the
really
basic
useful
loop in the application. Right?
Yeah, it does. It's great to actually understand from an application perspective how that looks and how that works. Because you kind of give a bit more detail around the software itself and how you piece it together, if that makes sense. That was great. Okay. That's really, really good. And I guess, James, it takes me to this next part around conversational PDM. Okay. And I guess that's a term which is used quite a lot. It'll be really great for you to define what that means and, how that comes into this whole scaling of predictive maintenance as well.
Okay, so I think conversational PDM, the term we use internally, it's really an extension of what I just described. I described a system in which you have a user and an AI working together, and you can think about what their particular strengths are, right? So that this particular strength of the user, their superpower, right, is at the end of the day, right? They can see the machines, they have on the ground practical knowledge. The main benefit that comes from the AI is maybe, I don't know whether it's what you would think or not, right? But the main thing is ability to see things at scale, right? So not necessarily its intelligence as such, right? But just the ability for it to see everything at once, okay? And in general, an AI system is typically going to have a lot less common sense than a human, okay? And so these things are nicely complementary somehow. What we talk about with conversational PDM is an understanding that there is another factor there, which is useful, which is expertise, expert knowledge, right? So it might be somebody from a machine manufacturer. It might be somebody at Sensei who's very familiar with predictive maintenance and how to get things to work. It might be somebody at the customer sitting in an office somewhere who, again, is maybe less hands-on, but has more detailed expertise in the specifics of the machines, right? But okay, so it's sort of bringing that third character in, right? And their superpower is obviously expert knowledge, right? Okay, but yeah, so you've got three characters. There might be individuals or multiple people, but you've got like three basic characters there, each bringing something. And we try to think of the app, right, and going forward more actively design it like this as a way of supporting a conversation between those three characters, right? Okay. And typically it will be the AI that points out there's a potential issue, right? Okay. And then the expert and the user discussing how to resolve this and potentially bringing the AI back in. But it really is a conversation, or should be a conversation, and a constructive conversation, right? Between these three characters.
To find out more, search Sensei Predictive Maintenance.